A correlation coefficient is a measure of how perfect or imperfect a data set is when we create a scatter plot. Here I have a scatter plot which is increasing in slope, and my line of fit contains every single data point from the scatter plot. This is called a perfect positive correlation, and it has a correlation coefficient of 1. It's a positive correlation because as one variable increases, so does the other, and they increase at the same rate as we're going up on our line of fit. In this next example, the scatter plot is decreasing. As one variable increases, the other variable is decreasing, but it's decreasing at such a perfect rate that the line of fit contains every one of the data points. This example is a perfect negative correlation, and it has a correlation coefficient of -1. -1 versus +1 is not a measure of how perfect the correlation is. It's simply indicating that the correlation coefficient being -1 means that as we increase for one variable, the other decreases at a given rate. In this example, we again have a positive correlation because the data points are very close to the line of fit, but not perfectly on them. So this is said to be a strong positive correlation, and a correlation coefficient for something that looks like this would be about a 0.97. And again, we see that the data points are closely hugging the line of fit, but not perfectly on them in a straight line. Some are slightly above, some are slightly below. Here we have a strong negative correlation where the points for the scatter plot are hugging very closely to the line of fit, but they're not exactly on the line of fit. So like our prior example, which was a strong positive correlation, this one is a strong negative correlation, and the correlation coefficient would be something like a -0.97, -0.98. And again, the negative for the correlation coefficient doesn't mean that it's not a strong correlation, but rather that the relationship is negative in that as one variable decreases, the other is increasing. Here we have a weak positive correlation, and although we can make out a general pattern that is increasing as we're going from the lower left to the upper right, the relationship as one variable increases, the other increases is barely discernible. And you notice that the points are not very sharply focused around the line of fit. A correlation coefficient for something that looks like this might be about a 0.55. In this example, we see a weak negative correlation. Once again, the scatter plot's points are not anywhere near with regularity near the line of fit. And I can still make out that there is a general pattern going from the upper left to the lower right. And I notice that over here there are no points, and up here there are no points. So this is a weak negative correlation, and a correlation coefficient for something that looks like this would be something like -0.52. In this last example, we don't have a line of fit because there is really no discernible pattern in order to draw one, and this is called no correlation and would have a correlation coefficient extremely low, something like a 0.06 or 0.04. It wouldn't be positive or negative because there's no pattern of increasing or decreasing to these scatter plot points. To use the TI-84, you first have to make sure that you have stat diagnostics turned on, and there's two ways to do that. And the first way is you click on the mode button, and then I scroll down. I notice over here it says stat diagnostics, and I need to switch this on. So I'm going to come down to stat diagnostics. It says off. I go to on and click enter, and we're on. Depending on what calculator you're using, you may have to find the stat on button by going through the catalog. And to do that, you would hit, and catalog for me on my TI-84CE is on the 0 button. So I hit second, then 0. And then this is in alphabetical order. I would hit the down arrow and hold that down until you get to, you're looking for diagnostic on, and here it diagnostic off and on. I want to click on diagnostic on and then hit enter and then hit enter again. And now we're in. And now we're able to do what's called a linear regression. In order to do a correlation coefficient on the TI-84, first we'll start with some data and I'll plot the points. So here are X and Y data that I'll plot. And we'll also add a line of best fit. And here we see for the line of best fit that there are some data points that are higher, some are lower, several are on the line. So if they were all on the line, then our correlation coefficient would be a 1, but they're scattered above and below. So this is not going to be a correlation coefficient of 1, but rather something probably in the 0.85 range. It would be positive because we have an increasing line of fit for slope. I want to take the data from this table and enter it into the TI-84. So on the TI-84, I would go into stat, which is right here. Next, I push enter, and it's giving me the option for 2 lists. One will be for X's, one will be for Y's. So here on the calculator, you can see I've entered all of the X data points. And just to show you how they're entered, I'm now going to enter the Y's. So the 4, 2, 8 for the first few. So 4, enter, 2, 8, 6, 5, 4. 5, 9. And now I see that I have matching data points for both X and Y. So with our data entered, we're now going to push second and quit. And now we're going to go into stats. And this time we want to go over here to where it says calc. So I go over 1. And now I'm looking for linear regression, which is button 4, or I can arrow down to it. So let's just do it that way. So arrow down, enter. And here on the screen, it shows that my X and Y lists are here. So list 1, list 2, and I want to come down to where it says calculate. So arrow down and click on calculate with enter. And here's my R value, 0.801. And that's our correlation coefficient for the data that is shown here on the scatter plot. If there are any other videos that you need made on how to use the TI-84 in specific instances, comment below and I'll make the video for you.